Now I can announce our next speaker. He will talk about smart engineering based on smart motors. We have Thomas Boschert from SEW, an electrical engineer, developer and project manager. He has been working at SEW for quite some time. You have the floor.
Hello. First, let me introduce myself. I am Thomas Boschert. The company I work for is SEW. As you will know, we are one of the leading manufacturers of gears, motors, frequency inverters, encoders, and controlling systems. These are classic products. At the time, we are developing smart products. The topic of my presentation will be what we mean by a smart product, and I will show the new possibilities and benefits for our customers. Now learn more about this and follow my slides. What do we mean by a smart product at SEW? What are the requirements? How can we transform the gear motor into a cyber-physical device? We defined 4 important characteristics for the word smart. They should show what we like to reach. We have to make it intelligent, so it can collect and process data. For example, we have to integrate electronics with a motor. We have to connect it so that it communicates with its environment. You have to make a simple user interface that the customer likes to have it. Link the right data of different processes. Then new ideas will be generated. On the left side, you see the life cycle of our products. The life cycle is divided into several steps you see on this slide. The first step is the product development. When the device is ready for sale, the client can make the dimensioning and the configuration after that, and order can be made. Next steps are manufacturing, assembly, and delivery. During this process, all generated data is stored in the digital twin. Now it's time for our customer to use this motor or frequency inverter. They have to install the device and to do its startup. Here, the customer will have the first benefit. All the data is now stored in the digital twin. Now they call up this data via the app to get support. The data is not only recalled, but processed, so that our customer gets upsides in all steps they have to carry out for installation, startup, operating, maintenance, and fail. And how does this work? Our customer uses the IoT app now, which runs on every platform: Android, iOS, and Windows. It is responsive, so you can use a smartphone, a tablet, or a laptop, a small PC. It is an HMI tool, so it's optimized to work direct at the machine. It's no tool for use in an office. It runs online via the digital twin, which is located in our SEW server. And if you have no internet connection, it runs via its cache. So, you have three ways to communicate. The red one, the green one, and the blue one. These are our motors with the frequency inverters you see on the right side. Now the red one. Here you can have a point-to-point connection via Bluetooth to the frequency inverter. You get the data from him and to do some adjustments. The green one. The customer is connected to our edge processing unit, and via this you are connected to the cloud. The data of several motors and frequency inverters are collected, processed, and optionally sent to the cloud. The blue one. The customer is connected via the cloud. This is always possible. You get the so-called static data. You hear later more. And if you are connected with an edge processing unit, then you get live data in addition. So, what have you to do? There is a QR code sticker on each motor. You scan this code. The content is the serial number. It is sent to the SEW cloud. If a digital twin to this motor exists, all available data is sent back to the smart device. This is one of the few times you have to be online. After that, most of the functions in the app can be used offline. Now our customer has to install the motor. From this point, he will be supported via the app. The user doesn't need to use a paper manual. Instead, he uses the digital one. The app. The user gets all instructions in the right order. He only has to follow them. And this for the mechanical and electrical work. For example, you have to mount your motor with 4 M5 screws, and you have to tighten them with 27 Newton meters. After you have finished the work, you can save your progress in the digital twin. So, if you go on with your work the next day, you will see the current state of your work again. If you have a Bluetooth connection or you are connected with the edge processing unit, you'll get the live data wireless. You see the current state of your application and you'll get a notice if a value is out of range. In this case, you use a motor with the sensor board. This is an electronics with special sensors, temperature, vibration, magnetic field, noise, and so on. And this is mounted in the terminal box. On the right side, you see the measuring of the oil temperature. By this information, we can predict the time when you have to change the oil. Now, the maintenance interval is not time controlled, it's load controlled. You see here, if you have to do the oil interval earlier or later, the time controlled interval. We also observe the vibration. We proceed the data with different mathematical tools like kurtosis. Here you see the evaluation after the startup of the motor, and here maybe 1 or 2 years later. So you see a difference. Maybe your motor has a bearing damage. On the left side, you see the wear and tear of our brake. With our digital brake rectifier, we are able to measure contactless the wear of the brake and can make a forecast when it has to be changed. And now the smart maintenance. Here the same approach. Go and consult the manual. Use the app. You see your task. So here you see the maintenance intervals and the time you have to do the maintenance. If an interval is expired, you are supported with a step-by-step. And after work, you can reset the interval and store it in the digital twin. Here you see the step-by-step guide for checking the oil level. And if you need a spare part, don't have to consult the manual. You see a complete exploded view drawing to choose your spare part, which is one out. Select the part you need. The part is saved in the digital twin, and via the SEW online service you can order the part. Select the part you need and put it on the list. Now we are at the end of the life cycle and at the end of my presentation. You got support in every step via the app. Many thanks for your attention.
Thank you very much, Thomas Boschert, for the interesting presentation. We got a number of questions which I like to ask you. Yes, I can see you. Hello, Thomas.
Hello.
Are you in Germany at home?
Yes, I'm at home in Germany. Yes.
Near Bruchsal?
We are all in home office. The development is in home office.
Near Bruchsal?
Near Bruchsal, yes, Karlsruhe.
Okay, Karlsruhe. Fine, thank you. First question. When I buy an SEW motor, do I get the digital twin for free?
Yes, there are several possibilities. The first level is for free. To get the static data, to get the manual in this digital version, to do the installing or to do the maintenance, to get the information, this is for free. But if you like to measure or to use this so-called sensor board, you have to buy a special edition of our motors, and then it's not free.
That means the motor is equipped with additional sensors and communication potential.
Yes. If you have a normal asynchronous motor, you can use this app and you can use the digital twin. You can get the installation guide, you can get the maintenance guide, and you can do the work, and you can save your work, and you can see what you have done. But all data, all the so-called live data, then you have to buy a higher equipment in the terminal box. Then you have to order the so-called sensor board. There are several steps, and therefore you have to buy. And if you like to manage more motors, then you have also to buy a special software.
Can I also use this digital twin software myself to optimize my application?
The main point is to do the maintenance and do the installation. We'd like to add some software tools, maybe in 21 or in 22, to optimize the system. Yes, but not at the moment. The release you will get in January. It's only designed for installing and maintenance of your motor.
Okay. How about the confidentiality of the data? When you, SEW, can monitor all my machines, Big Brother is watching me.
Yes. Yes, this depends on you. If you say no, I don't send data to SEW. This is your decision. Our server is in Bruchsal, and SEW is do a lot of that. The data are secure. But yes, you are right. If SEW likes to measure the data, likes to predict maybe some maintenance, and then SEW has to use the data, has to look in the data, that we can say yes, maybe in 4 months there should be you have to do some maintenance.
Okay, interesting. What kind of communication technology do you use inside the factory where I use my motor? Is it wireless or using wires?
So on the slide with the 3 possibilities, you see the main possibility is that you have a cable connection via the motor to our edge processing unit, and this edge processing unit is connected to the SEW server, the so-called SEW cloud. So this is the main thing. It's also possible that you have no connection to the SEW server. You put the data in your own server. And for operating with the motor, or with the motor and frequency converter combination, if you have to do some operating things, then you can get a Bluetooth connection via our new Bluetooth module. And then you have a wireless connection.
Okay. How do you transfer the data from the machine to your data center? Is it a continuous data stream, or do you send batches of information like every minute or like every half hour or whatever?
Yes, in the sensor board, the data is measured and is pre-calculated. And then we send step by step the data, the calculated data to the edge processing unit, and the edge processing unit do another calculation and send then the data to the SEW server. So we try to reduce a big data stream.
But that means you don't get continuous data. You get batch data, right?
Yes, yes, yes.
Okay. Somebody has been asking, what is the amount of data generated per motor and year? Are we talking about megabytes or gigabytes or terabytes?
So, sorry, at the moment we have 10 motors which run with this system, and we are at the moment testing this system, and we are collecting the data, and so at the moment I can't answer this question.
My last question to you, Thomas. Can we also save energy with such a system?
In future, maybe we can measure the current, we can measure the torque and so on, and maybe we can check this and we can we can look in the projection of the motor, and maybe the motor is too big for this application, and then we can offer a smaller one, and the customer can exchange it.
Okay, interesting, challenging. I wish you well for the future. Thank you for the interesting presentation. Greetings to Bruchsal. We have heard Thomas Boschert from SCW Eurodrive.